Hey, good evening all, and thank you for joining us today. I'm Suvarna Jadhav, working with Cloud.in as a strategic partnership and alliance manager. Welcome to the webinar Secure Your AI Applications, Maximize Savings, Minimize Risk for Your Business, hosted by Cloud.in. In today's rapidly evolving technological landscape, artificial intelligence has become an indispensable tool for businesses across the industries. However, as AI applications become more complex and sophisticated, so do the security risks associated with them. Our webinar will provide actionable insights and practical strategies to secure your AI applications and mitigate these risks. For today's session, we have Devansh Agarwal as a speaker. Devansh is working with Amazon Web Services as a part of the Edge team. He specializes in edge security, and for the past 5 years, he has been helping customers protect their applications from threats like DDoS attacks and application layer vulnerabilities. Welcome, Devansh. We also have Sakshi Chavan as a speaker from Cloud.in. Sakshi is working as a business development executive at Cloud.in. In this role, Sakshi delivers innovative cloud solutions and services to clients across various industries. Welcome, Sakshi. So before starting the session, I would like to mention a few points. All attendees are muted by default and cannot be unmuted during the session. We will have a question and answer session at the end of the presentation. If in case you have any questions, you can type in your questions in the question section and we'll address it at the end of the presentation. We will start with a quick company introduction. For this, I will request Sakshi to start a session, and post the company introduction, we'll start with the today's topic with Devansh. Over to you, Sakshi.
Thank you, Suvarna ma'am. Hello everyone, my name is Sakshi Chauhan. I'm working as an inside sales executive and business development executive at Cloud.in. So just giving you all the quick introduction about Cloud.in. So Cloud.in is a 25 years young company, and we having 22,000 plus SME customers, where we provide 24/7 NOC services to our customers. And we also provide domain registrar and have 40,000 plus domain managed yet. Coming to our progression and growth, at Cloud.in, we have 150 plus team members, out of which 100 plus are cloud certified. And we have our presence at the two locations where headquarter is in Pune and another presence is in Mumbai. So we currently working on 500 plus live workloads, where we have 6,000 plus endpoint protected. So Cloud.in's current service offerings are cloud consulting and advisory, in which our certified cloud consultant provide best advices to customer requirement. We provide reselling and billing services, in which we provide discounts on monthly billings. We also help our customers to implementation with the advanced technology and help them for the migration. And we also provide managed services and application services as well. So we have achieved some competencies from AWS, in which we have education competency, CloudFront solution provider, Amazon Web Application Firewall, public sector partner, and so on. So Cloud.in provide their services in some leading industry verticals like media and entertainment, e-commerce, IT sector, public sector, manufacturing, startup, education and training, and so on. And Cloud.in also working on some use cases in which we have serverless deployments, disaster recovery. We provide AI voice chatbots, then containerized deployments, cost optimization, content delivery, edge services, security and web setup as well. Uh, Thank you so much. Over to you, Swarna ma'am.
Thank you, Sakshi, for a quick introduction. Over to you, Devansh. We can start with today's topic. I'm just sharing presenter access with you. Yes, it's done from my side.
All right, thank you, Suvarna. Thank you, Cloudin team, for having me. Hello, everyone. I'm Devansh from the GSC team. I specialize in Edge security, which basically consists of Amazon WAF, CloudFront, and FMS. So, in today's session, we'll explore how to leverage WAF and CloudFront to enhance your security for public-facing generative AI application. So, spoiler alert: if you're not currently using AI, generative AI, or large language model, this presentation will cover architectural best practices that are applicable to a wide range of applications. So I encourage everyone to stay tuned as the content we'll discuss today will be valuable to various scenario in application security and architecture. So before we start, I just have a quick question. Do you know how much percent of the overall internet traffic is the bot traffic? You can type your answers in the chat, but I'll just quickly move on. So imagine we have 47%, greater than 47% of the internet traffic originates from the bot traffic. So it's, what does that mean? It means that this percentage of the traffic is a non-human traffic. And why does this matter to us? Well, as people who are running infrastructure, as people who are running application, we have to pay for that to serve those requests, be that human or be that bot. So this represents a bit of problem for us that we have to deal with or at least pay attention to. This also presents a problem in the large language model space as well, because there are non-threat, they are already coming out with using AI, LLM, and whatnot, right? So OS publish top 10 attacks for the LLM application, and these are the public-facing large language model, which is open to internet. And there are a lot of threat vectors which OS has identified. And one of the major threat vector which is relevant to this talk which we're going to talk about is model of denial service. I'm not talking about a layer 3 or layer 4 DDoS attack. I'm talking about something that may be a little bit more sophisticated, that they're trying to drive cost up for us running large language model. For you all running those models, this is just a fraudulent traffic that comes in, tries to make request and cost your money in that process. So there are a couple of things that I wanted to talk about today: threat to large language model from the bot and the percent of the bot that are on the internet. It represents a formidable problem that we need to figure out a way to address, and we are going to do that. So what we are going to dive in today is not just security. We're gonna talk about some fundamentals of how large language model work and the cost structure of how you can run those application, specifically using Amazon Bedrock. Once we understand how the costing work for those model, we might have to prompt a large language model. We are going to dive how we can use AWS WAF and bot control along with CloudFront to block unwanted traffic from and prevent costs from running out of control. Then we are going to leave you with a couple of really tactical things that you can do today to start understanding the bot problem that you may have on your application right now. All right, so let's get started. So one of the things that really important to remember about generative AI and all the large language model out there is they are trained on a lot of data, but not all data. These are fundamental things that we need to understand as architecture or as an architect here on how we build our Gen AI application for our specific business needs. So we can't just use generic large language model to answer all of the things that we might want to get for our business. We need to figure out a way to customize those generative AI application, and that could be training your own LLM. So I'll take an example over here. I want everyone to imagine for a minute that we are running an application where we are trying to sell a bike on the internet, and we want to create a feature on our website that allow customer to visit our website and ask a question in natural language about what kind of bike they might want to buy. Do they want to buy a road bike, or do they want to buy a mountain bike, or do they want to buy a high end bike, right? So the prompt will look like something like this: what is the best bike for an intermediate cyclist? My budget is rupees 15,000 and I want a mountain bike. We could put this prompt directly into a large language model such as ChatGPT and so on. But there are a couple of problems with that, right? Number one, the large language model knowledge is only trained up to certain point in time. You might not have a latest information. So the relevant response the customer will not get. The second problem would be the generic large language model might provide only answer for a generic across the different type of bikes, right? Even we don't sell those bikes, and that kind of defeats the purpose of what we are trying to do in the application that we are building. So we can do a couple of things with this. We can kind of give the large language model a cheat sheet. And what do I mean by cheat sheet? Basically, we can also give large language model some additional instruction here as well. So we can say something like perform the task below using the provided context. In the context, whatever you can do here is you can give the large language model some guideline on what it should be doing with what information it should be doing with. So we can provide the context and those instruction, and this prompt right here will be much more relevant. You can provide your internal sales wiki, you can provide the kind of bike that you sell. All those will come as a part of context. So just asking a general model without any of this additional information will not give you a relevant output. So this kind of comes with some additional thing that we need to consider. We took what was relevant simple prompt. So what we have done, we just have to guide the model that you to perform this task. And just remember this for the calculation purpose. Each token we kind of give it or take it, we calculate at each 4 character we kind of map it to 1 token. So what I have done is I've just calculated the character inside it, and I've just assume it to be 26 token. Similarly, whatever the task that we are asking the large language model to do, we also have assigned a token value to it, and as well as with the context. While we're talking about token, just hold on to your thought. We'll touch that in a bit. So when we do that, when we provide the context, when we provide the task, that we call as a RAG, retrieval augmented generation, where basically we are training large language model with our own data, with our own context. So we have something in AWS that we call it as Amazon Bedrock, which can provide you RAG. It's a managed RAG, and you can basically use it to provide a prompt or provide a relevant or accurate and customized response to a large language model. So you can see how a service like this would be really useful for the particular application that we are building around bikes, right? So we know that we have taken one model, now we are providing the context, now we are providing what exactly we want, right? So that it gives us the relevant output. But it does come with some things, right, that we need to consider around. And one of the most important thing is the cost. And how does the cost look like? So I've just taken a random example for one of the model. And in this case, I have taken an example for Cloud 3 Sonnet. And I have taken a ballpark number where 1 token is equal to 4 character. So when I told you, hold on to your thought regarding the token, this is what I was talking about. And this will be helpful because you will be able to calculate a cost. You will be able to calculate a cost using this method, right? So whatever the input you're providing, that actually convert that that actually gets converted to a token, and having that token gives you actual pricing. So what we did with the previous slide, I'll just go back. In this slide, what we did, we just taken an example where we are taking prompt as an input, context as an input, and whatever the task we are telling the large language model, and we are calculating overall how much token it will consume, right? So this brings us to this slide. So basically what we are saying that input token per request, it came around 1000, right? As you can just calculate like 900 plus 26. 900 is just a ballpark number. It can be more, it can be less, but it will come around 1000. And as we saw, right, for the 1000 token, it cost you around 0.003 cent per 1000 token. And let's say whatever the input token gets inside the model, you get an output based on that. For that, I'm just calculating a ballpark number of 150, and you can just see the pricing for that. It was around 0.015, and we assume that to be here. So this brings us to a roughly price per request. So each request that we cater will come around $0.018, right? This is what we are paying to use the large language model with the RAG that we are using. And along with that, if you compare this with our bot control, the target bot price per request it costs you around 0.0001 cent, right? So percent. And what we talked about 47% of the traffic, internet traffic, are the bot traffic. We might not block all the bot traffic, right? Because there can be a good bots as well. So we are just assuming that we are blocking 43% of the overall bot request. So what this bring us to? So it bring us to So this statement, right, for every $1 spent on the bot control or every $1 spent on the firewall, you can save up to $277 in the generative AI application. And how does this number came? How we came up with this number? So we assume that we are getting 1 lakh request, and we just calculated with 1 lakh into 0.018 and 43%, and we came up with this number. So if we assume that we can block most, but maybe not all bots for our particular application based on how we have tuned our bot rule, so we can block around 43% of the traffic as we discussed, right? We established in the beginning that about 47% of the public internet are the bots. So let's assume that we can block most, but maybe not all. This is huge, right? We are saving around a huge cost, massive cost saving that we need to be thinking about every time that we are having conversation around the large language model. So what I'm trying to convince you all today is, if you're thinking about LLM, or if you're thinking about generative AI, or especially if you're thinking about application that are using generative AI for the public facing, have WAF conversion concurrently. So it can help you filter out, it can help you save cost. So let's see a couple of architecture. How does this fit into the picture? So typically speaking, all the application with the public facing, if you are using load balancer, if you are with the EC2, if you're using Bedrock, this is how it will look like. The flow will look like this, right? So I'll just, what happens over here, since you do not have any WAF, since you do not have any filter, all the requests which is coming to your application will get served, including bot. So you are essentially paying for it. You're not filtering good bot, you're not filtering bad bot, you have to pay for it. There's no resiliency from the DDoS attack. So how we can improvise it? We can just put WAF into your load balancer, and what it will give, it will give you a observability, what kind of bot you are getting, what is the bot pattern, and so on and so forth. So this will help you to prevent attack or exorbitant traffic which is coming to your public facing application or a Gen AI application. So generally speaking, right, so this is not only limited to Gen AI or LLM. This origin can be of any type, right? It can be of your EC2 instance, it can be of your on-prem, and you still want to prevent that from the bot attacks, right? The WAF can help you leverage that and can give you the visibility. We can do better on overall architecture design here as well. And one of the way that you can do better is by using Amazon CloudFront. So Amazon CloudFront, people have a lot of misconception that Amazon CloudFront can only help you with the static content, but that's not true. Amazon CloudFront can also help you accelerate the dynamic content because of the presence of POP that we have across the globe, right? So if you have a dynamic application, you should remember that CloudFront can accelerate those dynamic acceleration as well. So CloudFront will distribute the load, create a global available application for you. You can attach WAF directly to the CloudFront. Instead of applying WAF to the load balancer, we recommend to attach WAF on the CloudFront. So what it will bring to you? So let's see, right? So use a static asset, you cache static asset to end user, which will eventually help you with the improved performance. You also get better resiliency from the DDoS attack. And why is it that? There's something I'll explain. So with the CloudFront, right, there's a SYN proxy which comes inbuilt, which we do not get with the load balancer. So if you have a CloudFront in front of the load balancer or in front of your Gen AI application or in front of your LLM application, it provides you better layer 7 DDoS mitigation capability. It provides you better resiliency from the DDoS attack. Having WAF with the CloudFront, we are basically mitigating the attack at the edge itself. This is not even going to your load balancer or not even going to your LLM application, right? So CloudFront has some really amazing feature, like we talked about SYN proxy, DDoS mitigation capability at the edge, and even so something considered is that you can attach CloudFront with the WAF, and you don't have to bother attaching WAF on the load balancer. So it's better security straightforward, right? You don't have to do a lot of integration. Just have CloudFront in front of your load balancer and have WAF with it. And as you can see on my screen, right, so there's a recent study that we did. CloudFront blocked around 155 million RPS attack, right? So that you can imagine the scale that CloudFront operates in. You can imagine the presence the CloudFront has, right? So having WAF with CloudFront and along with the Shield Advance can give you a complete protection from the DDoS attack, be it a GenAI application, be it any typical application, right? And so there are a couple of things that we want to talk about with respect to WAF. So what should you do in terms of using WAF rule. So there are a couple of basic one. If you aren't a WAF user today, you should know that Amazon has some Amazon managed rule that can get you started with some basic rule that are just good solid fundamentals, right? So to couple of them are Amazon IP reputation. So Amazon IP reputation rule is derived from the threat Amazon itself get it, right? So we also get daily around 10,000 plus DDoS attack. We know that what are the IPs which are bad. We know how IP has a bad reputation. So we provide that managed rule as a part of offering. So if you attach that Amazon IP reputation rule, any kind of application you're using, as I mentioned earlier, be it LLM, be it GenAI, or be it using your own custom application, having Amazon IP reputation list give you a better protection in terms of blocking malicious activity which is happening around the internet. Along with that, we have something called core rule set. This is derived from OS top 10. So OS publishes every 2 or 3 years the top 10 attack that is happening across the world. So you don't have to worry writing all those signature, maintaining those signature. Like recently we saw that Log4j came in, right? It was 0-day attack, and imagine if you had a WAF in that case. We launched the signature, and the signature was directly pushed to every customer, so you don't have to worry about writing those signature and start protecting those, right? That came under the non-bad input with the Log4j that I was talking about. So you can consider tuning on AWS WAF. To start with, you can go with the monitor only mode, and it will give you the free visibility. For example, to start with, to how do you start with, it's pretty simple. So if you're using CloudFront, you can just go to security. Under security, there's an option, just with 2 clicks you would be able to start, and you can choose which mode you want to start with, right? And that monitor mode only give you the visibility into what's happening with your actual traffic without making any changes to the production traffic. So tuning of WAF is really easy to do inside of the CloudFront console. This is one-click integration where you can, in the web application firewall section, say enable security protection, and you can attach existing WAF rule to your CloudFront distribution. You can also say turn on only in the monitor mode the CloudFront distribution, and you can also use some of those AWS managed rules that we discussed in the previous slide. So once you get started with the WAF, you can wait for some time, like maybe 1 day or 2 day, and you can then, once you put that into monitor mode, there's a graph inside the CloudFront console that is available for free. You don't have to pay anything, and it gives you the complete visibility, right? You can see like what kind of sample bot you are getting, what kind of attack vectors you are getting, right? So that you can take an informed decision. And and based on that, let's say if you want to craft some kind of rule, or if you want to improvise something on the WAF, that can be done easily. So, and if you go to the WAF console, you can see like total how many number of requests you got in, right? How many of them got blocked, how many of them allowed, what kind of request it was, whether it was a bot request, whether it was a non-bot request, what kind of client device type it was using, right? So all those information you get it pretty easily. And in the WAF console, you have option to customize the rule, whether, let's say, for example, you know that there are certain IPs which is trying to do some bad activity. You can create your own custom rule. You know that there are countries where you do not have a business with, but still you are getting a traffic, so you can simply apply a geo block rule. You also know that there are, so in a particular period of time, you don't expect the traffic to be more from a particular IP to be more than 100 requests, right? So you can simply apply the rate based control where you can define the limit of 100 and choose the window that you want to uh, cater to, right? So what it will do essentially, it will basically, if any IP which is trying to make more than X number of requests, though WAF will detect it and will start throttling any further request from that IP. So these are the controls that you get with the WAF by default, and along with managed rule and clubbing this custom rule provide you enough protection for any kind of application that you might be using. So what are the things you can do as a next step? So first, you can turn on the WAF to the block mode, which is the known offender, or you can start with the monitor mode. You can wait for 1 week, review your bot dashboard in the WAF console, or you can ask your manager team, or you can check with the Cloudin team to help you set up, review your WAF configuration, or you can get engaged with our specialist team. Right. So thank you all. That's all for today. So Suvarna, over to you. If there are any questions you want me to take.
Sure. Thank you, Devansh. We have had a fascinating discussion so far, and I'm sure you all agree that the insights shared by Devansh have been truly eye-opening. Before we conclude, I would like to dwell into deeper into a few key points that have captured my attention. Firstly, Devansh, you mentioned that around half of the internet traffic is non-human or bots. That's a staggering number. And I would like to ask a question like, how does this impact businesses like ours that rely on public-facing applications? Additionally, I would like to know what are the cost implications of serving requests to bots.
Yeah, thank you for that, Suvarna. And I'll give you a practical example which I have faced with one of the customer without naming the customer. So what happened was they were using CloudFront, they were using load balancer, they were using your typical application that we configure, typical architecture that we have, that we see the most common one, right? And suddenly what they started observing was normally they had around million requests per day, right? But suddenly the spike went on to 8 million and 9 million. And as you asked me like 50% or around 47% of the traffic are the bot traffic, right? That is what we saw when we did the analysis. Around the spike that we saw was more than 7 times or 8 times, right? And all of them were bot. Just imagine someone just wrote a script and started attacking that customer. And importantly, what happened to the cost? The cost also went 7 times whatever they were paying, right? And have they had a bot control or have they had a firewall in place, they were able, they would have blocked those traffic and they would not pay those amount, right? So that's why it's quite important. It's not only specific to a Gen AI or LLM. It can be any public facing application that you're using. And surprisingly, a lot of people think that they don't have a bot problem, but when they attach a WAF, they start seeing they actually have a bot problem. There are bots which are unverified. There are bots which are verified. So verified bots help you to improvise your SEO optimization. It can help you with better tracking. It can help you with the monitoring. But at the same time, we also have a bad bot. They can do scrapping. They can basically steal your content. They can do harm. They can slow down your website. Right. So we have to be very careful while we configure those applications.
Thank you, Devansh, for your answer. Secondly, I found the concept of model denial of service attacks against generative AI applications really interesting. So, can you please elaborate more on what that means and why it's a major threat? Also, I would like to know how can malicious actors exploit these to drive up cost for companies using large language models?
Yep. Thank you for that. So what happens, right? So any LLM or any model that you use, for example, I'll take a very common example for the chat GPT, right? You go to chatgpt.com, you start typing a prompt. If you don't have a right filter, if you don't have a right filter mechanism, what it can do, it can basically triple or increase your cost multifold, right? So if I'm an attacker, I can just simply write a script which can keep on prompting without even understanding the output, right? I can just start doing that. And if you don't have a right kind of filter, if you don't have a right set of rules applied, be it WAF or be it with firewall or be it with WAF, right? It can obviously increase your cost. And how attacker use it? Attackers use a different method to perform a denial of service attack. It can it can either they just do the prompt by simple by just writing some shell script, or they can just directly send a lot of get requests on the IPs that where you are hosting the model, right? You still pay for it because generative AI application or LLM, we have to agree these are all costly affairs, right? If you don't control it, it can be a dent to a pocket, and it can basically increase our billing. So we have to be very careful over there.
Thank you for your explanation, Devansh. Additionally, I'm intrigued by your proposed solution of using AWS WAF, Amazon Bot Control, and Amazon CloudFront to mitigate these threats. Can you walk us through how these services work together to block unwanted bot traffic and protect our generative AI applications?
Right. So with the AWS, what happens? There are certain things we do very differently, right? When we put CloudFront, that would be your first landing zone, right? Any traffic which is coming to the CloudFront would be any traffic which is coming to the CloudFront, and if you have a WAF attached, what CloudFront will do? CloudFront will send all the requests to your WAF, and whatever the rules you have configured, be it a managed rule, be it a custom rule, all of those traffic will get evaluated by those rules. If it is not a malicious traffic, then only your request will go to your origin. If it is a malicious traffic, or if it is exhibiting any kind of bot behavior, if it is exhibiting any kind of malicious AI behavior, that also WAF can detect it, right? That's where we will be able to control the malicious traffic. That's where we will be able to provide you a better security, better visibility. When I say better visibility, that visibility you might be missing, and that visibility will give you more analytics of what kind of traffic you are getting, and you would be able to take an informed decision. When I say informed decision, means you're able to apply some more custom rule, some more managed rule. And how all these put in, if you how all these components work together. First, the traffic goes to the CloudFront, then CloudFront sends the request to the WAF evaluate all the requests. If it is good, then it sends to your origin. If not, it will send back to 403 to CloudFront, and you can also customize the response, and CloudFront sends the 403 back to the client. So this is how the entire component works. So basically, you have to think, or is this is a building block of your entire application architecture. So if you're just using ELB, I will consider have CloudFront in front of the ELB, and it actually saves you cost as well. The ELB DTO charge, or if you just compare the CloudFront DTO charge, right? CloudFront DTO charges are much cheaper than the ELB DTO charge, and having a WAF with the CloudFront at the edge gives you optimal security. Why I'm saying that, as we discussed already, CloudFront comes with already inbuilt security features such as SYN proxy, distributed presence the CloudFront has, right? So all this mechanism and component gives you a better and improvised security option.
Okay, thank you for the answer, Devansh. The session is open for Q&A. If anyone is having any questions, you can type in your questions, or else you can raise the electronic hand and I will unmute you. So far, there are no questions. Devansh, we'll wait for a minute or two. Let me just check if anyone has raised a hand. Yes, we have one person here from audience who has raised a hand. Vimal, I will just unmute you and you can ask your question. Yes, Vimal,
Hey,
you can
hi
talk.
Devansh.
I
I hope I am audible.
Yes, you are. Go ahead.
Yes, you're.
Okay. So Devansh, my question is, since we just discussed that with the bot attacks, there are the chances that it can, manipulate the resources in the production environment so that the resources are scaled up, and there would be, the cost associated with the deployed resources. So my
Mhm.
question here is, can we use like Shield Advance protection so that the increased resources as the cost associated with the deployed resources that can be absorbed by this the Shield Advanced protection. So is there any feasibility? Because I had read this somewhere in the Shield Advanced document that there is a process that we can request for the credits for the resources which are got spinned up just because of this bot attacks.
Yeah, thank you for bringing that up, Vimal. And trust me, we are the only cloud provider where we claim that if you are part of Seal Advance customer, right? And if you attach your resources with the Seal Advance, for example, the bot attacks that you are getting with one of the application, right? And let's say normally you have around 100K traffic, right? But suddenly due to DDoS attack or suddenly due to exorbitant traffic, your bill is spiked up to, let's say, 5x or 10x. Any spike that you get because of attack, and if you're part of Seal Advanced customer, we provide you a credit to that. And there are some conditions where which all resource we provide, but yeah, answer is yes, whatever the question you ask. But having said that, right, you still need a lot of control in your web place, because if you're just waiting and to uh, to get a credit, right, there could be a business impact to you, right, where your business can go down because of this bot attack. That business value is very hard to determine. We might not reimburse that. We can only reimburse the scaling cost. We can only reimburse how much resource you have consumed. So having multi-layer approach is the way to go.
Okay, so Shield Advance it has like a lot many consideration and the functionality, but there are the attacks which contains like 0 day attack because
Right.
there is no pattern established. So maybe the Shield Advance can help in that sense. Okay, so if the Shield Advance is there in the accounts, then okay, so that I mean, in terms of this extra burden of like payment and credit, so that can be sorted. As that having the CDN plus WAF, it's a the first choice in terms of protecting your
So
any application. Yeah.
let me give you a very layman example so you will be able to relate it, right? So Shield Advance is specifically designed to protect you from a volumetric attack, right? When I say volumetric, when you get large in volume traffic, right? But there are chances that you can have a slow volume attack where attackers might be sending 3 or 4 requests just to exploit something, just to maybe uh, play with your pace to increase the overall latency, right? So, or maybe just trying to scrap your content, or maybe just trying to steal something. That might not be detected by Seal Advance, right? You still need WAF for that. A particular improvised rule or AMR, AWS managed rule, or your own written rule. So those will help you to detect those kind of attack. For example, you might having a SQLite injection attack. Seal Advance may not detect it. Seal Advance will detect it if you are having a SQLite injection attack or any kind of attack which is in very high in volume, which is not your normal traffic. It is very deviate from your normal traffic. So we have to have, like as I mentioned, multi-layer approach. One for the WAF, which helps you with the application security. Next with the Shield, which helps you with layer 3, layer 4, and layer 7 volumetric attack protection. Clubbing that with CloudFront, you get enhanced protection because CloudFront already comes with SYN proxy.
Okay, got your point. Thank you very much.
Yeah.
Thank you, Devansh. There is one more question from Aditya. Let me just unmute him.
Mhm.
Aditya, you can talk now.
Yeah. So Devansh, how we can mitigate the slow DDoS attacks? Let's say someone is sending the slow volumetric attack to any of my domain on CloudFront. So what kind of rules we can configure to mitigate those attacks?
The key is the observability to start with, right? You first need to understand whether you're getting a slow Loris attack or slow DDoS attack or not. But to answer you, we are already resilient. So CloudFront and if you're applying a CloudFront right in front of the load balancer, we are already resilient for the slow Loris attack. We already have a security feature inbuilt. However, we still want you to configure a rate-based rule. We still want you to configure a IP reputation rule. We still want you to configure the certain AMR rule, right? By using combination of this plus the AMR and the plus the custom rule, you will be able to mitigate the slow Loris attack. But can we mitigate if someone is sending just one request or two requests? The answer is no, because that might not be impactful to you. But if they are sending a malicious signature, can we mitigate? Yes, with any request, with be it one request, two requests, because of the signature that we have on the AMR or on the custom rule that you write, you will be able to block then and there itself.
Okay, so we have to use the combinations of multiple rules.
Right, combination of multiple rules. To start with, a basic rule is the rate-based rule, where you can have like 20 or 30 requests for 1 minute. So if anyone is sending more than 20, 30 requests in one period of time, they will automatically start getting throttle, right? And if let's
So
say they're going below even that, then we'll check the signature. Is it malicious? Is it not malicious?
okay, let's suppose I have configured the rate-based rule. Let's say 30 requests per minute. So how it will work? So
So
it
what
will.
happens in the WAF, right? There are a lot of misconceptions. I'll try to throw some light on that, right? So how we actually work with the rate-based rule is whatever the limit you have configured. Let's say as you're given the example of 30 requests in 1 minute, right? So what happens? Let's say a particular IP is making below the 30 requests. Those requests will keep on allowing, right? If particular IP breaches the 30 requests in a period of 1 minute, let's say I started making of 50 requests, right? Then what WAF will do? WAF will detect it and it will block the IP. It will basically block the IP until that IP goes below the 30 again. So we have a rolling window. We keep on checking. So from, let's say now the time is 4:40, right? From here t minus like 4:40 minus 1, 4:39. Then we wait for 20 seconds. Then again we check. right? So we have a rolling window, and as soon as we find the IP going below the threshold that you have set, we start allowing that.
Okay, so basically it will not wait for the 1 minute to analyze the rules, right?
Sorry, it will not wait for.
1 minute to analyze the rules. Let's
No,
consider
it
I
keeps on. It keeps on analyzing previous to from now minus 1 minute.
okay, yeah. Thank you.
Right, and there are chances you might still get exorbitant traffic, but eventually WAF will see the IP is making the large traffic and it will start blocking it.
Yeah.
Thank you, Devansh. If anyone is having any questions, please raise your hand. So far, there are no questions, Devansh, and no one has raised the hand. So I guess we can conclude the session. Thank you all for joining us today for this insightful webinar. We have covered a lot of ground, from the challenges posed by bot traffic to the innovative solutions available to combat them. I want to extend a special thank to Devansh for sharing his expertise and answering our questions so thoughtfully. Your insights have been invaluable. We hope that the information shared today will empower you to protect your applications and safeguard your business. Remember, staying informed and proactive is the key in the ever evolving landscape of cybersecurity. We would like to get your feedback on the session to improve your experience. So I would request to share your feedback through the link shared in chat box. And thank you once again for your participation. We look forward to see you at our next webinar. Have a wonderful day.
Thank you.